So today we'll be discussing this very interesting question from JEE Advanced 2019 paper 2. The question actually is based on permutation, combination and probability. So after reading the question, the language of the question is very important. It is important to understand the language of the question. The reason being, lots of misconceptions and errors might occur. So we can see that a sample space S is given, which has the elements 1, 2, 3, 4, 5, 6. The elements itself are not important. The how many elements are present, that is very crucial. So we have been given that S has 6 elements, where each element is equally likely to occur. So each element has a probability of 1 by 6. So now we have been asked that A and B are two independent events associated with S, such that the number of that they are in such that they are independent and A and B are subsets. So the question actually here is actually telling us that the intersection of the probability of these two events should be equal to the probability of the individual events, which is the definition of independent events. In other words, we have to select subsets such that they satisfy this condition as well as another condition, which is that their cardinality must follow disorder. Okay, so now how do we proceed exactly? Let's assume that in any case the set B has small b number of elements and the set A has small a number of elements. So since B elements are present, the probability of each element to occur is 1 by 6. So B by 6 is the probability that of NB to occur. Now, and so we can just write this is equal to probability of B. Now what is probability of A? Probability of A is going to be similarly A by 6. Now suppose we take the intersection. So the intersection has the probability of AB upon 36, right? Now see, their intersection can have any number of elements. So suppose say A is 3, 4, 5, right? And say B is equal to 1, 4. Then A intersection B is actually just the element 4, right? And there is a 1 by 6th probability. No, not 1 by 6th. So the intersection is 4. So one element is there, so the probability of that occurring is 1 by 6. So let this B intersection A, probability of B intersection A, be some C by 6, where C is some element and C by 6 represents the probability of this element to occur. So C by 6 must be equal to AB upon 36, right? So we get 6 times C is going to be AB. Now begins the crucial part. So till now what have we understood? We have understood that A and B are two events such that they involve choosing subsets from the sample space S, and they must satisfy the condition of independent events as well as the cardinality condition, where number of elements in A must be greater than number of elements in B, which can be greater than or equal to 1. And the second step, we have to make our working easier, we have assumed that number of elements in B is small b and number of elements in A is small a. Now while choosing, we have chosen B elements. Suppose we have chosen B elements, so the probability of B occur, B to occur, B number of elements B to occur is B by 6, and the probability that number of elements A occurs is A by 6. Now the question states that the intersection, this is a given condition which both of them must satisfy, that the intersection of these two must be the product of these two individual probabilities. Now the intersection might contain any number of elements ranging from 1 to 6, right? Now since the probability of their intersection to occur, like in this example we have 4, right? So what is the probability that 4 will occur? The probability that 4 will occur, which is equal to the probability of A intersection B to occur, is 1 by 6, right? Now what is probability of A, these elements to occur, is going to be 3 by 6, right? The probability that B occurs is 2 by 6. So the product is going to give me 1 by 6. So this is what we have in our hands, in short, this condition which we have derived, 6 times C is equal to AB. Okay, now we can say that C can be 1. Suppose C is 1. If C is 1, then A times C must be 6, right? Now C equals 1 stands for the fact that the intersection of A and B has exactly one element common. So we have the following cases. A has to be greater than B, so A can be 6, B can be 1, A can be 3, B can be 2. Now, how many ways can each of these occur? We have 6 elements, so we have 6 ways of choosing them, and we have 1 way of choosing B. For the second case, that's marker number 2, Roman 2, we have 3 ways of choosing A, and remember, the intersection has to be 1. So one of the two elements has to come from this 3, right? One of the two elements must come from this 3. So the other element must come from any of the other 3 remaining elements, like say 1, 2, 3, 4, 5, 6. I suppose choose 1, 2, 3. Suppose I am choosing 1, 2, 3. So if I choose 1, 2, 3 and say I have the choice of choosing one of the 3 elements, I have the choice of choosing one of the 3 elements to appear in B. So let's say 3 is appearing in B, right? So now from 4, 5, 6 the other element has to come. So this is it. So this will give me 6. Okay, let's highlight this 6. And this is going to give me 63 is 20, 180. Now this is when C is 1. Now what if C is 2? If C is 2, then you will be having 12 is equal to AB. This puts up the cases where A is 6, B is 2, and when A is 4, B is 3. Now in this case you can have 6C6 yet again we can have 6C6 times how much? 6C2, which is going to give me, how much is 6C2? Let's see, 6 factorial upon 4 factorial whole upon 2 factorial, which is 15. So 15, and this will be yet again same procedure, 6C4 into 4C2. Why 4C2? Because 2 is the intersection and so we have chosen 4. So we have chosen 4. Out of the 4, 2 must occur. Let's see. Suppose in this case we have 1 2 3 4 5 6. Suppose I choose 1 2 3 4, and suppose I choose 3 and 4 to occur, right? So I am left with one element to choose, so one can come from any of the remaining 2. So 2C1, so this is going to give me again 180. Now say I have C is equal to 3. This means 3 elements A and B have in common. So if 3 elements A and B have in common, then 18 time equals to A times B. This can yet again have the following cases: A can be 6 and B can be 3. Then we have 6C6 times 6C3, which will be giving me yet again, this time it is going to give me 20. And the case 2 can be, is there any case 2? No, there is no other case 2. So this is the only situation. Now continuing, if C is equal to 4, then again we have 24 is equal to AB. This also has one case where A is equal to 6 and B is equal to 4. This will be giving me 15. And the last case, C equals to 5, where 30 is equal to AB. This is going to give me 6. Now on adding them up, we have 6 plus 6, so 186. 186 plus 15. This should add up to 6. So now on adding them up, we have 422. Now a question might arise: why is C considered not equal to 0? The actual reasoning will be that since C represents the number of elements in P in probability of A intersection B, and since this is equal to the probability of A times probability of B. Now if you observe very carefully, it has been clearly stated that none of the cardinality is equal to 0. It cannot be equal to 0. Thus the individual probabilities can also never be 0. Thus this can never be 0. So C equals to 0 is not possible. Similarly, C equals to 6 is not possible, as it will imply that cardinality of A is equal to cardinality of B, which is clearly not stated in the question. Right, oopsie. Which is clearly not stated in the question. Thus, the final answer will be 422. Thank you.